look at these 3 questions now, which are more application style questions. Number 1, I've got a curve has gradients. Y prime is 3 cosine 4x plus 2, and pass through the point pi comma 8. Find the curve equation. Okay? So this is in radians, so make sure you're well versed in radians as well. So y is just the integral of it, right? So I can just integrate it straight away, and I'm going to get 3/4 lots of sine of 4x. Kind of this general plot then. 2 actually into 2x. Obviously see the integration out. Now, using this little bit of information here, I can find what this constant is by putting it all in. So I get 8 is 3/4 times sine of 4 pi plus 2 pi plus my constant c in the direction. Now, because I'm being lazy, I'm going to stick what sine of 4 pi is in the calculator. So sine of 4 pi. Well, I think it's going to be 0 because I know where sine crosses the axis. It is 0 because it crosses the axis every pi. So at 4 pi, it's going to be still 0. So I get what 2 pi is as well. That's of interest. 2 pi is just on its own. So I don't need to do anything with that. So all I'm going to get is 8 equals 2 pi plus c. So what is my value of c? It's 8 minus 2 pi. That's easy. Alright, so all I need to do is sub that back in and I get my equation. So it's 3/4 sine 4x plus 2x plus 8 minus 2. Alright, that's question number 1. The question. Now, if I look at question 2, I've got the integral of 2 e to minus 3x minus 3 e to minus 2x. Now, we've got a minus 3 up there, so that's going to integrate to minus 2/3 e to minus 3x, because then I can differentiate that for real one, and then minus 3 times that, which gives me the 2 back, and then it says it is. Now I've got minus 3 e to minus 2x. Now, minus 3 will divide with the minus 2, so minus 3 divided by minus 2 is positive 3/2 e to the minus 2x, because then that'll differentiate to minus 3 e to the minus 2x. Yep, nice and easy. Last one then, we've got, right, a single logarithm, the integral of 3/x plus 5/2x. Now 5/2x is the same as 5/2 of 1/x. So we'll still be using natural logs anyway when I look at questions like this. Right then, this is a little bit nasty as well because I've kind of got natural logs to deal with. Now, I don't know about you, but I'm not a big fan of natural logs. So, anyway, let's see how we get on. So if I want to integrate this one, I get 3 times the natural logarithm of x, because I got 3 lots of 1/x, where log x is 1/x integrated. I'm going to get 5/2 of 1/x, so I'm going to get 5/2 log x, plus my constant c of integration. I can combine these logs together now. Now, combining them, I could probably do this in one step if I really wanted to, but 3 plus 5/2 is 11/2. Lots of log x, plus my constant c, which my constant c technically is log of e to the c. Because obviously those cancel out with log and e next to each other. I can then bring my 11/2 up to the power in the top, so I'll get log x is to the power of 11/2 now, and I can add on my natural log of e to the c still. So, all I need to do now is replace this, and e to the c is just another constant, so this is literally using our multiplicative rule. I just get log of a x, so 11/2. Okay. So that is nice 3 examples of how they can ask you these types of questions with natural logs and various other functions.